Alrighty folks, I want to give you a quick tutorial on the difference between independent and dependent events. I'm going to use a marker here as I change up the program here, guys. Good day to you all. So what is an independent event and what is a dependent event? Dependent versus independent. Okay, what are they? Well, an independent event is something that involves something not changing. And I want to give you a few examples first. And I don't mean die, that would be inappropriate. But a number cube doesn't change, does it? If I roll a number cube, if I get a 5 the first time, I get a 3 the second time, I can get a 5 the next time, and nothing has changed. I'm not taking the 5 off when I have independent events. I can get the same 5 every time if the roll comes out that way. For instance, or on the other hand, when I have something that utilizes dependent events, then something is going to change, and I'm going to give you an example of that. How about this? If I eat a donut, if I eat a donut, and let's say I eat a jelly donut, I can't put a jelly donut back in the box. And since I can't put the jelly donut back in the box, the next time I choose a donut, my chance of picking a certain kind of donut may change. So the independent and dependent events that we're talking about relate back to possible outcomes. So possible outcomes and the number of them do not change. Whereas with dependent probability examples, the number of possible outcomes does change. Let me give you a card playing example. I like this example right here. Hopefully you can see some of this work. I have the camera at a kind of a weird angle on my desk. But I have a standard 52 card deck of cards, and I'm going to ask what the probability is of choosing a red 8. And the probability of choosing a red 8 is going to be 2 out of 52, which also equals 1 out of 26. Okay, so that's an example of simple probability. That's just one event happening. Nothing is changing. There's no possible outcomes that have to change. Now, if I ask you a different question and I say, what is the chance of choosing a red 8 and, whoops, I didn't have my red 8. Where's my red 8? I lost my red 8. There it is. Sorry, guys. Doing a little technical difficulty here. And here's my other red 8. So if I asked you to find a red 8 and another red 8, what would the probabilities be of that? So if this is simple, if I said the probability of choosing a red 8 and another red 8, the chance of picking it depends on whether or not I put the card back in the deck. So if I replace the card, or if I don't replace the card, there's the difference. If I replace the 8 or not replace the 8, that's going to tell me whether or not it's independent or dependent. And we'll figure that out in a second. So my chance of picking a red 8 out of my deck of cards is what we've already said, 1 out of 26. And I know you can't see that, so I'll move this up a little bit. When I pick the next red 8, if I don't put it back in, sorry, let's backtrack. Let's do it if we replace the 8. if I choose the 8 red and I put it back in my deck of cards, putting it back in my deck of cards, what is the chance that I'm going to pick another red 8? Well, since I put it back in my deck of cards, it's going to be 1 out of 26 again, because I haven't changed the number of possible outcomes. To figure this out, I have to multiply these two probability ratios together, and since I can't remember the answer to this, I think it's 676. Let's double check that real quick. It's 26 times 26. I know that you're figuring out yourself right now. 26 times 26 is 676. The answer would be 1 out of 676. And this is an example of independent events. And you can see how we would, I don't know how to write independent events apparently. And you can see how they're independent because I didn't change anything. This is independent of this. This is independent of this. They're giving you this answer. Now, what if we don't replace it? What if I pick my 8 out, and instead of putting it in my deck of cards, I throw it away? There it is on the top of the screen. Now, if I want to pick that other 8, my chance is not going to be 1 out of 26 again. It's going to be a little different. If the first time I pick it, it's 1 out of 26. The second time I pick it, it's going to have to be a different ratio because I have 1 red 8 and I have only 51 cards here now because I took out one of my cards. There it is right here. Can you see it? There it is right there. So my next value is vastly different. And when I multiply these two values together, I get something a lot different. I get 26 times 51, and that equals, wait a second. I get 1,326. Isn't that a weird answer? They're completely different. There's a big difference between the probability of independent events and dependent events. And that main difference is in the number of possible outcomes that are used in the second picking of whatever we're picking, whether it's cards or whether it's using some other object. The first pick was the same. The second pick was different, though, because we either didn't replace the card or we replaced the card. And I have a really interesting way of remembering how to tell that apart. So with dependent events, can you see that? Dependent events and independent events. Dependent means don't put it back in. Independent means it goes back in. Dependent don't, independent it goes back in. So if we're talking about cards, the card goes back in, it turns into an independent event scenario because the numbers won't change. Dependent, if you don't put it back in, the numbers are going to change in the possible outcome and your numbers are going to change in your probability answer. There are lots of examples that we can use for this, and I don't want to waste your time and I don't want to take up too much video space. So we're going to talk a lot about this week. We're going to know the difference between independent and dependent probability, and we're going to do lots of cool examples of games to show it. I look forward to answering your questions in class, and if you have further questions, feel free to do some research on your own, take a look at some other videos, and be ready for those games. Have a great day.